What? Okay, here we go. So, first question was 25 minus x squared. The first quadrant part of that. So that looks like, if you think about it, it's a parabola opening downward, right? And the first quadrant part of it's right here, where this is 25 on the y-axis and this is 5 on the x-axis, right? So if we're going to rotate that around the x-axis, so that's part A. We'll do it right up here. We know it's going to be pi times some integral, and we need big R squared and little r squared, but there is no little r squared for this one because the shape we are rotating sits flush against what we're rotating about. So again, we're going to rotate around the x-axis. That's this right here. So if you put your pencil on the axis, like I said in class, and draw perpendicular to that, to the outside of this shape, that's the first time you hit it. It's the only time we're going to hit that shape, because the other one, little r, is actually 0. Little r sits on the axis. So big R, the top of every one of those, is 25 minus x squared. So the volume that we're looking for is the integral from 0 to 5 of big R squared dx. All right, and I'm not going to put the numerical values in the video because right now I'm just concerned about you guys getting these answers, and I don't. I'll type out a couple just to show you how to do it in the calculator, but I'll wait till we get one that's a little more complicated. Okay. Okay. We also want to do that rotation for part B around the y-axis. So we'll do that one down here. Well, if we're going around the y-axis, which is a vertical line, we're going to have to use dy. And the reason for that is, cool, look, here's what we're rotating about right here, right? And if we draw perpendicular to that out to the shape, again, no matter where we put our pencil on that axis we're rotating around, we hit the shape once, and we always hit the same curve, but we're crushing down y right now, dy. Every little one of these represents a tiny, infinitely little thin rectangle that we're going to rotate around like that and make like a little tiny cylinder. That looks super sloppy, but okay, hopefully that makes sense. We're going to get a little cylinder there. Now the volume of every single one of those cylinders is pi, big R squared minus little r squared, times the thickness, which is dy. So for B, big R is right minus left. Now this curve is defined as 25 minus x squared, which means x, if you solve that out, is going to equal the positive or negative, get out of here you, square root of 25 minus y. Okay, now we want, so this x values are either positive or negative, that's what this says. Well, we only want the first quadrant part, so we just want the positive version of that square root. Cool, so remember, when you solve a parabola, when you switch x and y for a parabola and solve, you get two functions because a parabola has two sides. So that's what's happening there. Now, 25 minus y, square root of 25 minus y, is the right-hand side of every one of these rectangles. So big R is the square root of 25 minus y. Let me write that a little bit neater. Minus 0, because that's the left-hand side, right? So 25 minus y minus 0 is right there. So the integral that gives us this volume is pi times the integral of big R squared, which is root 25 minus y. I'm not going to put the minus 0 because it doesn't really do anything, dy. And that's going to go from 0, y is going from 0 all the way up to 25. And since we're using y, we've got to set it up like that. Okay, let me grab a chair here. Sit down. Okay. For part C, they're asking us to go about the line x equals 10. So we're going to do number 1, part C, and I'm going to draw this shape again down here. So we have this shape, which is this part of the parabola, right, where this is 5, this is 25. And we're going to go around the line x equals 10, which will be out here somewhere. Okay, and like we said in class, go ahead and I'm going to switch colors again just so we can see this a little bit easier. If OneNote opens its menu, there we go. Put your pencil on the axis you're rotating about. Draw to the outside of your shape. So here I'm going to hit it once and then again. I hit it twice. So that's big R. And you can see no matter where I draw that, I'm always going to be, the right side is going to be 10 and the left side is going to be 0. So big R for 1C is the left side, or the right side of that, which is 10 minus 0. So basically big R is always 10. Because if you spin that thing around, let me erase this for a second. What we're really doing is creating a big disk like that. And the radius is always going to be 10. You can see that, right? Out to here is going to be 10. Over here is going to be 10. That doesn't change for big R. That's happening because the left side of it is like flush. It's a straight line. Okay. So again, big R is 10 minus 0, and little r, pencil on the axis, draw to where you hit the shape the first time. Again, no matter where I draw that, pencil on the axis, draw to where I hit the shape. I'm always going to be on the right side is 10 minus the left side is that curve. But because I'm using dy, because I'm going around a vertical line, I'm crushing down y. It's 10 minus, we need it defined in terms of y, which is 25 minus y. Okay, so 1c is pi times the integral of big R squared, 10 squared, minus little r squared, which is root 25 minus y, in parentheses, squared dy. And y is going to go from 0 to 25. Okay, and then part D for number 1 says around the line y equals negative 8. So we'll draw that down here. 1, D. So y equals negative 8. So here's our shape again. Here's 5. Here's 25. Negative 8. Y equals negative 8 is down here. So you can see the shape we're rotating is not flush against the axis we're rotating around. So we're going to have a big R and a little r. Well, you always have a little r, but sometimes it's 0, like you saw in the first example. So pencil on the axis, draw to the outside. No matter where I draw that, the top of it will always be 25 minus x squared, minus the bottom of it will always be negative 8, so minus negative 8. Okay, we can simplify that if we want to. Like, that is the same thing as 33 minus x squared, but there's nothing wrong with leaving it as this original part here. It's not going to hurt anything. So that's big R, little r. Again, pencil on the axis. Say this over and over. Draw to the first time you hit your shape, which is right there. No matter where I draw it, the first time I hit it is actually 0. So little r is 0 minus negative 8, which is just 8. So this is going to be pi times the integral of 25 minus x squared minus negative 8 squared. That's big R squared, right? So that's pi r squared minus 8 squared. That's little r. We're using x's because we're going around a horizontal line. Okay, and we're crushing x. When you draw your radii, you see that we're crushing down x, and that means x has to go from 0 to 5. All right, so that's number 1. Let's step it up here. Number 2. We want x minus 1 and x minus 1 cubed, and I say, hey, be careful there. There's 2 parts to that, which is kind of a pain in the butt. So let me show you what's up. So for number 2, let me just steal that whole question. Actually, I'm going to run out of room. Come here, come here, come here. Number 2. Boom. Okay. We'll come way over here. So x minus 1 and x minus 1 cubed look like this together. I'm going to exaggerate this, but x minus 1 cubed comes up like, what, you plug in 1, you get 0. So it comes up like this and hits 1, and then it kind of curves up like that. And x minus 1, the line, is going to look like that. So this actually closes off 2 different regions. We have this first region here, and we have this second region here. Okay. And while that adds a little bit of complication to it, it doesn't make it terrible. So if we're going to rotate this around the x-axis, check this out. Let's draw the x-axis here. Let's go here. Here's the x-axis. Cool. Now, the problem with this is since we have 2 different shapes, we got to treat them each separately. And the reason that's happening is because they each have a different top and a different bottom. Even though the same curves, the top and bottom switch. So we got to handle this as 2 separate integrals. So if you look at just that first section there, right here, big R is going to be that right there. So in this section, big R is 0 minus that line, which is x minus 1. Okay, little r, which I'll write up here because I'm going to run out of room, is that, the first time you hit that shape. So that's 0 minus x minus 1 cubed. Okay, that's on the left side, and that's going to go from where they intersect, which is this point here. What's that going to be? Negative 1, negative 2? No. That's a negative 1. Did I mess this up? Good, I did. I did x plus 1 cubed. All right, well, the same thing. I just drew it in the wrong place because I'm trying to rush. Get out of here. All right. They're going to hit here. So x minus 1 cubed looks like this. While x minus 1, the line, looks like that. So still 2 sections. You can see them. So let's go back. Let's switch to red now. Boom. So on this left side here, boom, big R is that right there, what I just drew. So big R on the left side is going to be 0 minus the line, like we had before, doesn't change. And little r is going to be 0 minus the cubic. Okay, so for part A, the first part of it, we need two integrals again because their shapes are changing. These hit at 0 and these hit at 1. So we're going to integrate from 0 to 1 because that's what x is doing. And big R is going to be negative x minus 1, and we're squaring that, minus little r, which is going to be negative x minus 1 cubed squared. And you can simplify this down if you like. There's some rules we can use, but that doesn't really matter too much for us. So that's the first part, plus. The second part, we need big R. So big R is going to be from the axis we're rotating about. Remember, we're rotating about the x-axis here. So the top of that is x minus 1, and the bottom is 0. So big R is x minus 1 minus 0. And little r, you draw it, boom, first time you hit it is the cubic, so it's x minus 1 cubed minus 0. So that's going to be pi times the integral. Now we're going to go from 1 to 2, because that's this x value right here is 2. Okay, so big R is x minus 1 squared minus little r is x minus 1 cubed squared dx. Cool. We're going to rotate that around the y-axis, which is kind of a pain in the butt, but we can do it. So let's draw it out. So we have essentially this shape right here with the cubic coming up like this. I'm going to exaggerate it, boom, and we have the line looking like that. Okay, and we want to rotate that around the y-axis, which is going to be right here. So we're still going to need two different integrals because, again, in this case, the left and the right sides of this shape change. So down here, if you put a pencil on the axis and draw to the outside, that's the line. But remember, that line was y equals x minus 1, but I need x. So x would be y plus 1. So big R for that piece right there is y plus 1. Little r, if you put your pencil on the axis and draw it the first time you hit it, you hit the cubic. But that was y equals x minus 1 cubed, which is going to turn into x is equal to, what's that going to be, the cube root of y, and then add 1 plus 1. So little r is the cube root of y plus 1. So the first part of this integral here, this is 2b, is pi times the integral. Okay, we'll worry about the values in a second here, but big R is y plus 1 squared minus little r, which is the cubed root of y plus 1 squared dy. And y in this shape here is going to go from negative 1 to right here is 0. So that's where those little radii are going to start. Okay, they're going to start here, and they're going to go from negative 1 all the way up to 0 is what's going to happen with them. Okay, now I'm going to erase that because it looks all junky. But so we're going to go from negative 1 to 0. That's the first part, plus pi times the integral from 0 to 1, because that's the second part. It goes from 0 to 1. That's this y value up here. And big R is going to be right there. So that's the cubic part, right? So that's the cube root of y plus 1 squared, minus 0 technically, right? But then squared, minus little r, which is from the axis to the line. So it's always right minus left when you do this, though, okay? So the line was y plus 1 minus 0, technically squared dy. So that's B. C is about the line x equals negative 8. So x equals negative 8 is a vertical line. So let's take our shape, which looks like this. Again, the cubic and then the line, like that. Okay, and they intersect at the points 0, negative 1. 1, comma 0 is right there. And 2, comma 1. We're going to go around negative 8. X equals, negative 8 is on the other side. That makes sense. It's a negative 8, right? Not positive, okay. So negative 8 is going to be back here, actually. But it doesn't really matter where the axis is, as long as you draw your shape accurately and you follow my very simple rules. Put your pencil on the axis you're rotating around. Draw perpendicularly from there to the shape. If you hit it once, that's great. If you hit it twice, that's the outside. That's big R. Pencil on the axis, draw out to it again until you hit it. Okay, now the y-axis and the x-axis will be on this graph normally, but I'm just keeping them out so we can kind of see a little better what's going on. So this is going to be, and this is 2c. All right. This is going to be pi times the integral of big R, which is the line y plus 1 minus -8 squared. Okay, that's my big R. Minus little r is the cubed root of y plus 1 minus -8 squared dy. And they're going to run from -1 to 0 because that's what the y values do. Now, in case you're wondering, the reason why I'm doing the function here minus -8 is because I'm always just doing right minus left. It just depends on where the axis is compared to the shape. So the shape's on the right side, the axis is on the left. It's always right minus left. Cool. So that's the first part. And then we got to rotate the second piece up there. So plus pi times the integral. Again, pencil on the axis, draw to the outside. So that's the cubic. So that is the cubed root of y plus 1 minus -8 squared minus this little r is going to be this line. So that's going to be y plus 1 minus -8 squared dy. And that's going to go from 0 to 1. Okay, because that's the y value is going from 0 to 1 there. Okay, and then 2d is about the line y equals 25. So last one, we still got this shape here. We got the line going through, and y equals 25 would be way up there, but it's just above it. So all that really matters is that it's up here somewhere. Okay, so we know again these points are 0, -1, 1, 0, 2, 1. And we're rotating this around, so I'm going to close the window for some reason. Come here. You can do it, you can do it. Okay. Pencil on the axis, draw to the outside. Kaboom. The top of that is that 25, right? The bottom is the line. So the first integral is going to be pi integral from 0 to 1 of 25 minus the line, which was x minus 1. We're subtracting the quantity, so put it in parentheses. There you go. Minus little r, which is pencil on the axis, draw to the first time you hit it. So that's going to be 25, the top of that, minus x minus 1 cubed. That looks sloppy. Squared dx. Plus, the next one is pi times the integral from 1 to 2. That's the next section. We're going from 25 down to the cubic. That's our big R. So it's 25 minus x minus 1 cubed squared minus 25 minus the line x minus 1 squared dx. Cool, and that was what, 2d, I think? Okay, so that's the integrals you should be setting up. Again, I'm just more worried about setting up the integrals than actually calculating them out. Okay, we did number 3 in class except for C, I believe, but we'll run through it real quick here anyway. Okay, we'll do it right down here. So we want x squared and line y equals 8 is our region. So just sketch that out first. Boom, and then line y equals 8. Boom. Okay, about the x-axis, which is down here. Now this is just one shape, which is a lot nicer than the last one, which is a pain in the butt. So big R is from the axis we're rotating to the outside. Boom, that's 8 minus 0. So we have pi times the integral of 8 minus 0 squared. That's big R minus little r. Again, no matter where you draw it, the first time you hit that shape is always going to be that parabola there. So that's going to be, the top of that is x squared minus 0, and we're squaring that to dx. Cool, and that's going to go from where these things intersect. And if you solve where x squared equals 8, you're going to get negative root 8 and positive root 8. And you can rationalize or simplify that to 2 root 2 if you're feeling good. But I'm just going to say negative root 8 to root 8. That's going to give me the volume of that first thing. About the line x equals 10, another one we did in class. So it's 3b. About the line x equals 10, we have the parabola and the line that look like this. X equals 10 is out here. Again, around a vertical line, we've got to use y, dy, because our radii are going to look like this. That's the big R right there. Little r is the first time you hit it. Now, a lot of times kids are like, well, I'm hitting the same curve for big R and little r, right? Because this whole curve here is x squared, and little r is the first time you hit it, and big R is the second time you hit it. The reason why it looks like they should be the same thing is because they are the same curve if you define it y equals. But if you define it x equals, there's 2 x values for each y value. So if y equals x squared, that means x is plus or minus root y. The positive negative does this. Here's where the thing splits. This side is the negative square root of y, and this side is the positive square root of y. And this line over here was some number, I forget, 10, 10. And once you set it up like that, it's not too hard to see what we got to do. So this is 3b, so we're doing pi times the integral from 0, which is the lowest y value right here, 0, 0, up to here, which is root 8, 8. So we're going up to 8. But big R is the right side, which was, I forgot already, 10, 10, minus the left side, which is negative y. So that becomes that squared minus 10 minus positive root y squared dy. And that's it. Oh, I'm so popular. My phone is blowing up. 2 text messages in half an hour. Okay. It's probably my mom. All right, let's check out 3c. So 3c is the same shape. Looks like this, but around the line y equals 120. It doesn't matter which, just above it. It's up there somewhere. Okay. So I know there's a lot going on here because I'm asking a bunch of questions, but I give you the same shape over and over again so you can kind of practice what big R and little r are going to be. So in this case, pencil on the axis, draw to the outside of my shape. No matter where I draw that, big R is going to be 120 minus x squared. Okay, so remember it's pi r squared. We're doing the area of a circle, really. Boom. Little r is going to be from this to this. So that's going to be 120 minus 8 squared dx. And we're going from negative root 8 to root 8 again. So once you rotate one shape, like let's go back up to this first time, like right here. Once you rotate the shape around a horizontal line, that was the x-axis, right? The limits don't change if you rotate it around a different horizontal line. What changes is there's the radii, and that's just going to be what we're subtracting. Okay? So let's see here. We're going to do number y equals 8 and 9. Ooh, okay, we can handle this. So snag this one. This might be the last one I do in this video. Okay, you're going to love this. So we want the graphs of x squared, so we know what that looks like. The lines y equal 8, which we'll say is here, and the lines y equals 16, which will be here. So we want to rotate just this portion of it, which seems a little weird. Okay, that's what we're rotating around the x-axis. So let's take a look at this. This is kind of a pain in the butt too. I'm just showing you all the bad stuff that can happen. I'm going to over-exaggerate the parabola curve though, just to make it a little bit easier for me, okay? So if this is y equals 8, and this is y equals 16, like that. So the points of intersection matter. If y is 16, x has to be 4 over here. Where did that come from? Because we're on x squared. If y equals 8, this has to be root 8, 8. And over here, this would have to be negative 4, 16. And this point here would have to be negative root 8, 8. That's an 8 there. That doesn't look better. And the bottom point here would have to be 0, 0. So now we don't care about the bottom part of this, right? We just care about the pieces between the lines. So this is what we really want. Yes, there's a parabola here that comes down like this and keeps going, but we don't care about that part. We care about the pieces in between those lines. So we want to rotate around the line y equals x. Not y equals x, y equals 0, which is the x-axis. So the problem with this, check this out. If I draw my big R, right, which will be from the axis perpendicular to the outside, no matter where I draw that, look, axis perpendicular to the outside, it's going to hit it, boom, axis out to the outside. No matter where I draw that, I'm going to erase these two, but you can see the top will always be 16 and the bottom will always be 0. So big R for all of these is 16 minus 0. But little r is dependent upon where I choose to draw it. If I draw little r right here, I hit 8. So this little r here is 8 minus 0. But if I draw it over here, now I hit the curve right there, right? So if I draw it over here in this interval, I hit the parabola, not 8 anymore. So the little r over here is actually x squared minus 0. And the same thing happens over here. If you draw a radius over on this section, you're going to get little r is x squared minus 0 there too. So between negative 4 and negative root 8, little r is based on that because that's the bottom of the shape. But then, oh man, what is happening? Okay, So what this looks like is we actually need 3 integrals to do this because the bottom changes 3 times. So this is going to be pi times the integral from -4 to -√8 of big R, which is 16 squared, minus little r, which is x squared minus 0 squared, plus the middle part is going to be pi times the integral from -√8 to √8 of big R squared, which is 16 squared, minus little r squared, which is 8 in that interval, dx. Plus one last integral, and we could have doubled up the first one because it's the same exact shape over there. But this is going to go from positive √8 to 4. That looks like a negative there. And big R is going to be 16 because it's what it is everywhere. And this one's going to be x squared minus 0 squared dx. Okay. If you want to go around the line, x equals 22. So this was what, 4a? 4b. I'm going to use the same shape here just to save a little bit of space for us, okay? But x equals 22 is out here, right? What's nice about this switching the y here is even though x needed 3 integrals, y just needs 1 integral, because if you put your pencil on the axis and draw to the outside of this shape, no matter where you draw it, it's always going to hit this left side, which is really going to be x equals -√y. When you draw your little r, pencil on the axis, the first time you hit your shape right there, that's always going to be x equals positive √y. So rotating this is actually relatively simple compared to 4a. It's going to be pi times the integral. Big R is going to be the right side, which is 22, minus the left side, which is -√y squared, right? Minus little r is going to be 22, which is the right side, minus the left side of it, which is √y squared dy. And y is going from the bottom, which is right here, 8, to the top, which is 16. So it wasn't too bad. And then 4c is back around a horizontal line again, -15. So I'm going to try and update 4a for a second, just so you can see what's going on. So 4a gave us 3 integrals. Because we were going around a horizontal line, we're going to have to do 3 integrals again around a horizontal line. That's always going to happen with this shape. Okay? How all the changes, though, is big R, instead of being, remember, it was 16 in part A, it was 16 minus 0. Right, everywhere. Now it's going to be 16 minus, it's not going to be 0 anymore, it's going to be -15, because that's what I'm rotating about. So if I can zoom in here and update this, this becomes not 16, but 16 minus -15. All right, and little r over here, if I can erase all this junk here real quick, again, pencil on the axis, which is -15. Up to here, little r is x squared minus -15. So that's all that happens in here. It's x squared minus -15. And remember, our formula is always pi big R squared minus little r squared. The middle part, big R was 16, but now it's 16 minus -15, which you could simplify if you wanted to. Minus -15 squared. And little r is going to be from -15 to 8, which is that distance right there. So it's 8 minus -15 squared dx. And then the last one, same thing. It's going to be 16 minus -15 squared. And little r is going to be, again, put your pencil on the axis, draw it to the first time you hit it. That's right there. That's going to be x squared minus -15. Minus -15 squared dx. Okay. So that's the first 4, and this was 4D at this, or 4C at this point. Okay, you're only doing 6 for homework, the first 6. So that's the first 4. 5 looks a little scary because I'm giving you a trig function, but it's not too bad. You know what sine looks like, right? It goes up and then it goes down. The sine x equals 1/2. I mean, y equals 1/2. So we know it equals 1 right there. So a half is right here. Cool, so if you draw that line here, it chops off that, okay? And x equals 5 pi over 6 is right here. So what you're really looking at is that shape right there, where this is 5 pi over 6 for x, comma a half, because that's the y value, and this first one is pi over 6, okay? Oh, it says x equals 0. Ugh. So then you also got to include, so this is pi over 6 right here. But you've also got to think about, let's think about the shapes this traps. There's actually, if I did this correctly, 2 areas in here. That line in sine, yeah, this is a pain in the butt. So it's sine of x, 1/2, which is right there. X equals 0 chops off something, and x equals 5 pi over 6 chops off something. Okay, so we want this piece here, and this piece here is what we're rotating. So that is going to be 2 integrals there. And the answer key's on there. You can check the answer key. And 6, I defined x equals y squared, but that's not crazy difficult. That's the same thing as if you solve that, plus or minus root x. So that's all that is. Look, you get positive root x, negative root x. It's just a sideways parabola. And y equals 2x minus 8 is going to hit the axis at 4. It's going to hit down here at -8. And you got to find where these things intersect. So you can use a calculator, or you can just set them equal to each other and solve. But we need these x values here. I'm not going to tell them to you. All right, so try those out, and we'll talk about it tomorrow for home in class.